This relatively small satellite is a first of its kind for NASA. It's designed to open up secondary payload opportunities or give piggyback rides to orbit for science experiments and technology validation. It serves as a bus that puts research on the affordable fast track. Its name?
FASTSAT, Fast Affordable Science and Technology Satellite. FASTSAT is a spacecraft bus, giving access to space for experiment and technology type of payloads that desire access, require access to space in a very fast schedule, but an affordable, low-cost model. Here at Marshall Space Flight Center, the engineers designed, developed, and tested the spacecraft. We went through our environmental test chambers and we space hardened this instrument for low Earth orbit.
Most satellites are built in a fast schedule is 36 to 48 months, and we did it in 12 to 15 months. FASTSAT is a microsatellite, which is a satellite in the 200 to 400 pound range. It is 26 inches by 28 by 38 inches, which is a class of satellites called an ESPA class. ESPA class is intended to be able to fly on a number of launch vehicles.
The FASTSAT satellite will be launched on a Minotaur 4 launch vehicle, and that's controlled out of the Kodiak, Alaska launch site. Once the satellite is deployed on orbit, the mission operations reverts here to the Mission Ops Center, and we'll be coordinating through the ground sites to receive telemetry and get ready to start commanding for the satellite.
The primary benefit for the FASTSAT science is its enabling capability for what I would call lower cost, quick response science. There are essentially 6 experiment payloads, 3 of which are what we call heliophysics experiments, and those contribute to the entire science realm of understanding the energetics of the sun and how the sun's energetics affect us here on Earth, not just in the common ways of the daylight and the nighttime, but also in terms of what we call space weather, which essentially affects our communications. Many of us have experienced dropouts of cell phones, changes in GPS signals. Those are all things that are contributed by the heliophysics of the interaction of the sun and the Earth. Now, the other experiments, one of them is a NanoSail, which is a NASA Marshall experiment.
NanoSail D has several different science objectives. The main science objective is to make sure that we can deploy a satellite out of FASTSAT without recontact between it and the main satellite. Our second objective is to deploy the satellite, deploy the sail, so that it deorbit within a known period of time. And that will allow us to take the first step toward understanding how solar sails will operate in space.
NASA and the Department of Defense are collaborating, where that we've helped design and build the spacecraft, and they're providing access to space. They're providing the Minotaur launch vehicle.
FASTSAT serves as a low-cost platform that opens up new opportunities for researchers to conduct science and technology experiments on an autonomous satellite in space.